All right, welcome back. This is a continuation of 2.3 talking about calculating interest. And we're starting now with calculating interest on investments involving regular payments. This is a little bit more difficult because you can see even in this chart here, excuse me, that the first year here has this rate of 10%. My mistake. This chart is not adding payments. This chart is showing a different rate for every year. And the present value, you'll notice then that it generates the interest, and then the present value, or what your value is at the end of that first year, is the value that started with the second year. And then you have a new interest rate, and that calculates a new interest of 119. And then the next year you put that much into the investment at the new interest rate. Everything's changing. When we calculate this, we could do calculations for every single year with all the information, compounding interest, etc. It's difficult. We are going to use a financial calculator to calculate such as this. So if you would, please, you can go to Google Classroom and open up that financial calculator link. The calculator you have open should look like this. Here's the first question. Sophie deposits $750 into her savings account every 3 months. When we talk about doing something every 3 months, how many times a year do we do that? 4, you're right. So every 3 months, that's the same thing as writing quarterly. We know that quarterly means that our n equals 4. The account is earning 0.028% compounded quarterly, meaning 4 times a year. Okay, how much money is going to be in the account at the end of 3 years? So you can picture yourself 4 times a year, right? 4 times a year for 3 years. That would be 12 payments you're going to make, right, of $750 each. And there's the rate. Okay, let's put that into our financial calculator. All right, the present value, the amount we start with, is 0. The payments we're making are $750. The future value, this is what we want to find out, the amount in the end. We leave it blank then. The rate, annual rate, and you can see here that it says to give it as a percent. So we're going to write it as 2.8. Excuse me. The periods, we just talked about that. We're going to make 4 payments each year for 3 years. So there's going to be 12 payment periods. And when will this compound? When will we calculate the interest? It said quarterly, 4 times a year. So that compound, the interest is calculated at the same time that we're putting in the payments, 4 times a year. It doesn't have to be the same time, but in this case it is. Okay, and then we will press FB. That's what we're looking to find. Something's awry. I'll have to do a little investigating as to why that shows a negative amount for future value. The answer is correct, though, except for the negative. The future value of this investment will be $9,354.71. Let's switch back to our worksheet now. Okay, how much money will be in the account when we're done? That would be $9,354.71. Now, on a quiz or something like this, or when you're doing your work in your book, this information here, what you enter into the financial calculator, needs to be recorded. Okay, so our payments, you can write this down, what you typed in. Like such. Okay? Okay, how much of this will be interest? Let's figure that out. So if you put $750 in 12 times, right, 4 times a year for 3 years, that's exactly $9,000. So you put in $9,000, how much of that would be interest then? Well, I could subtract them, although I can see it pretty easily. The interest is $354.71 that you did not have to do any work for. We call that a passive income, that interest. Your money was invested in this savings account, and that interest grew without you doing any work. Not a ton of money, $354, but way more than you would have had you put that $9,000, say, between your mattresses. The next question, Michael is saving up to buy a combination washer and dryer in 2 years. So he's got a 2-year plan. He plans to deposit the same amount at the end of each month into an account that pays 1.9% compounded annually once a year. What regular payment must Michael make each month to meet his goal of $1,300 for the washing machine? Before we flip over to the financial calculator, let's think about our entry amounts. So we've got a present value. What we're starting with is 0 in the account. He's making payments, and that's what we're asked to find. What regular payment should he make each month? Future value of this account, Michael wants to be $1,300. The percent that he's getting is 1.9%. The periods of payment, how many times is he going to pay every month? For 2 years. So once every month, that will be 12 times each year. This is going to be 12 times 2 years, 24 payment periods. And compounding, it says compounding annually once a year. Right? Okay, go ahead and enter that into the financial calculator and see what it comes out with. I'm using the other financial calculator link in Google Classroom here. Here you see the different options to, as your X or what you're looking for. Let's go to payments. We're looking for the number of periods and the interest per year and the present value starting with 0. Future value, and notice here it asks you to start with a negative, so I think that's just what you need to do. Our future value, we want it to be $1,300. You click calculate, and it shows you need to make monthly payments of $43.26 each month. You can see the total amount of money you need to put in. So you're looking to save $1,300 for your washing machine, but actually the interest is saving 261.85 of it. And you, in actuality, have only accumulated $1,038.15 of your investment, or the money you put in. You can see the chart. The black line is your amount you still want to put in. Of course, it's going down as you put payments in. The red is your interest. You can see it does grow. If we left it in for more years, the curve would climb quickly. Here you can see the schedules, your 24 different payments, what you're doing every time. So you're putting in this payment of $43.26. You can see the interest compounding. So of course the first payment, 0 interest. Second payment, interest 82 cents. But then the next payment, you're getting interest on the interest you've already accumulated. And of course the interest is growing compoundly. Okay, let's flip back and do the last question. A portfolio, which you need to add to your vocabulary list for this unit, is a collection of investments or a group of investments. All right, Xavier has the following portfolio. He bought $1,000 of Canadian saving bonds at the end of each year for 5 years. So the first one he bought would last 5 years. The second one he bought will last 4 years. Third one, etc. The first 3 Canadian saving bonds earned a fixed rate of 5.2 compounded annually. So right there, that word, I don't see that we're making payments. It says the word compounded. It tells me that we should use the compound interest formula to calculate this. The next 2 Canadian saving bonds, so year 4 and year 5, they have a fixed interest rate of 5.6%, also compounded annually. Okay, so there's those 5 investments that we need to calculate. And then also, 2 years ago, he bought $10,000 of government investment certificate, earning 7% interest, compounded monthly over a term of 2 years. Again, there we don't see any payments, so we don't have to use the online financial calculator. We should be able to do those calculations by hand. Okay, let's go ahead. We've got 5, 6, 7 calculations that we need to find their current value of and add them all together to see the value of his portfolio after these 5 years. So let's do those calculations. If you want to stop this and attempt it, give it a whirl. Okay, so the first calculation has a present value of 1,000. You can open up your book and look at the formula for compound interest if you'd like. 1 plus the rate, that was given in the question, and compounded annually, so we divide by 1. And this first one that he bought was 5 years ago, so it's going to last 5 years times by the 1. Now, the second one will have the same. You put $1,000 in, 1 plus same interest rate, same compounding annually. This is just 4 years. Remember, he bought at the end of each year, so 4 years times 1. Third one will be similar, but will only last for 3 years. Whoops, I wrote that number wrong. There's supposed to be a 0 in there. Times 3 times 1. All right, now the fourth Canadian Savings Bonds we bought just 2 years ago, but there was a different interest rate there. 0.056 went up a little bit, nice. And that was just 2 years ago, compounded annually. And then just 1 year ago, in the 5th year, he also 0.56 compounded annually 1 year. All right. Now he also has this GIC 10,000 7% interest compounded monthly over 2 years. Okay, so we've got $10,000, 1 plus 7% interest rate compounded monthly, which means 12, and would be 12 times a year, for 2 years, and it's happening 12 times a year, so the power of 24 up there. Let's see if we remember that information right. 7% compounded monthly, term over 2 years. All right, let's do these calculations, and then once we find what these are all equal, we're going to sum that to find the grand total down here of his portfolio. Pause it and do that math, please. Xavier's portfolio is worth $17,338.28. Now, the second question was, what is his rate of return? Now remember that rate of return is the interest you've incurred divided by the amount you've invested. If you remember, Xavier invested $1,000 5 times, as well as $10,000. So that would be $1,500 he's invested. If we take our total of the portfolio and subtract the invested amount, that would be the interest that he's gathered, divided by the invested amount, $15,000, and we multiply that, of course, by 100 to find the rate, and we find then that that is 14% rate of return. Okay, I'd like you to open up your books and practice these questions, please. Notice that the answers are provided.